A Boeing 747 slams into the English countryside.
Hello!
It was like a battlefield.
Complete and utter devastation.
Where was this 747?
Investigators have all the clues they need to figure out what caused the accident.
The aircraft took off with the same defect that it had arrived with.
But they can't explain why no one on board did anything to prevent it.
They seem to be ignoring the alarms completely.
The first officer was about to die, and he didn't say anything. How can this happen?
The answer lies not at the crash site, but thousands of kilometers away, buried in hundreds of years of history.
Mayday, mayday.
Gary Dan is enjoying the Christmas holiday at his home just north of London.
I told you I don't like them.
It was a Christmassy family get-together. It was just exchanging of presents. And that's when I heard the noise of the plane coming over. It got louder and louder. It was almost like the plane was going to take the chimneys off, it felt, and heard the noise that close to the house.
Living less than 2 kilometers from Stansted Airport, Dan is used to hearing jets, but not this close.
I looked out the window, saw the plane coming over with fire coming out of the engines. As it came over, it sort of banked heavily left, and then just kept banking and banking.
A Korean Air 747 slams into a forest in the village of Great Hallingbury.
This was just a huge, huge explosion that you're watching it happen with a plume of fire coming towards you. I collected a torch. We ran downstairs saying, the plane's gone down, we've got to go and help. My brother and I ran outside and ran towards where it happened. We were racing towards where we could see the plume of smoke and fire because there's still lots of aviation fuel popping around the area. We ran and jumped into a very large crater, just shouting out,
Hello!
You know, any survivors, please shout.
Hello! Can anybody hear me?
The aircraft had created a 30-foot plus crater. The wreckage was spread over at least half a mile. It was like a battlefield.
We dialed 999.
A plane's gone down in Hatfield Forest in Great Hallingbury.
It takes nearly half an hour for rescue workers to arrive. They quickly determine that there are no survivors. A multi-million-dollar plane and thousands of kilograms of cargo are completely destroyed. It's up to the UK's Air Accidents Investigation Branch to figure out why.
This is a very sophisticated aircraft, flown by a trained crew, and somehow they had lost control of this aircraft. How can this happen?
Stansted Airport, on London's northeastern edge. The airport is a major European hub for low-cost passenger carriers and cargo flights from around the world.
It really was buzzing. Lots of people there queuing up, checking in, people arriving, lots of meeters and greeters, lots of coaches. So it really was a fairly busy hub just on that run up to Christmas.
Flight 8509 is a Korean Air cargo plane.
The aircraft was a Boeing 747 freighter. As the name suggests, it was not configured with passenger seats, but the interior was full up with freight.
Departing from Seoul, South Korea, the jumbo jet stopped in Tashkent, Uzbekistan, before arriving at Stansted. It will now continue on to Milan, Italy, with a new captain and crew. In the hold, a load controller directs the offloading and onloading of cargo. He makes sure that the more than 63,000 kilograms of freight is stowed safely and securely. More than just stacking boxes, the job can have a critical effect on the flight characteristics of the plane itself.
Loading the aircraft has to be done in a manner that keeps the weight distribution within limits, so that you can't put all the heavy stuff in the back and all the light stuff in the front, for example, because it would tend to tip up and make control difficult, and that would be very dangerous.
Captain Park Duk-kyu is a highly respected commander.
Sir.
And a former colonel in the Korean Air Force, with thousands of hours of flying time on the 747. Park Hun-kyu is Flight 8509's flight engineer, responsible for monitoring the aircraft's mechanical systems. First Officer Yoon Ki-sik is new to the 747, with 195 hours flying time on the aircraft.
On this night, there were the 3 crew and a Korean engineer.
The engineer has overseen some minor maintenance work on the aircraft and will now accompany Flight 8509 back to Seoul.
All right, gentlemen, if departure goes smoothly, we may just make our scheduled time. Let's proceed. Stansted clearance delivery, Korean Air 8509 requesting clearance to Milan.
Korean Air 8509, we have no flight plan. Cannot clear you.
Copy that. Stansted, stand by for flight plan.
Every commercial airplane needs to file a flight plan before it can leave the ground.
Contact our people and get them to refile the flight plan. Hurry up.
Ground control.
Korean Air 8509 must wait while the document detailing their planned route is filed.
As far as the air traffic control system is concerned, it's just another aeroplane. It has to obey all the same operational rules and procedures as any other aircraft, passenger or freight.
Korean Air 8509 cleared to Milan via Dover. 6 Romeo.
Korean Air 8509 cleared the Dover 6 Romeo, squawk 2230.
Now nearly an hour behind schedule, the crew gets clearance to taxi. It's 6:25 p.m.
Korean Air 8509, line up on runway 23.
Position and hold, runway 23. Korean Air 8509.
Captain Park is well aware they have no hope of arriving in Milan on time.
Korean 8509, clear takeoff, runway 23.
Finally.
$80 knots.
Roger.
V1. Rotate.
The plane takes off from Stansted Airport at 6:36 p.m.
Positive rate confirmed.
Gear up.
Gear up. Passing 900 feet.
The aircraft had taken off and climbed to about 2,500 feet.
Shortly after takeoff, the aircraft was making a turn.
Left turn at 1.5 DME.
Copy that. Left turn at 1.5 DME.
The aircraft started its turn to the left.
Heading standby, sir. Heading 158.
The captain's artificial horizon tells him that the plane isn't turning.
Bank's not working.
Bank! Bank! Look! Bank!
For some reason, Flight 8509 has gone from takeoff to total destruction in less than 60 seconds. Korean Air Flight 8509 lies in pieces just a few kilometers from one of the busiest airports in the world.
We had no wreckage, really, that was above knee height. Where was this 747?
After any major crash, Britain's Air Accidents Investigation Branch deploys a safety specialist to the site.
I'd like to take a look around if I could.
Sid Hawkins' job is to assess the level of danger at the crash site.
One of the key things to do is to get investigators into site to start work. And for somebody like me who's looking after their safety, there's always a challenge for me to try and hold them at bay until we've done our initial site assessment.
His first concern, the 30 tons of fuel the 747 was carrying on takeoff.
Is that fuel still on site? If it is, that poses quite an immediate hazard for the team there. In addition to that, what sort of cargo are we dealing with? Are we dealing with just general cargo, or are we dealing with dangerous goods?
Let's shut down the scene for the night. It's too dark and dangerous. Notify your people.
There was no lighting, and it actually was very, very dangerous for the investigators and the rescue services.
Investigation of the crash site will have to wait till morning. But before they leave the area, they make a key find. One of the plane's 2 black boxes.
This was crucial, the discovery of the recorders on the day.
Nice. The cockpit voice recorder is extremely important dealing with any accident where we have no crew that have survived. It tells us what they were saying, it gives us an idea of the environment in the cockpit, and it records the sounds from the cautions and warnings that go off in the cockpit.
But this black box has suffered extreme damage. It's too soon to say whether the CVR holds valuable clues that could help explain the sudden crash, or if the last recorded moments of Flight 8509 are gone for good.
Meg!
Meanwhile, the AAIB has begun work closer to the Stansted terminal on the airport runway. The team's operations investigator is David Miller.
We had been out on the runway, having received a report from the airport that the runway was covered in debris.
With Miller at the airport is engineering investigator Steve Moss.
The things that go through your mind are possibly what's known as an uncontained engine failure, which means that the engine has burst and left bits on the runway.
Investigators wonder if the plane actually began to disintegrate on takeoff. Among the small pieces of wreckage on the runway is an especially chilling piece of evidence.
Something that looked very much like a human jawbone.
And of course then your mind starts to race, what on earth's gone wrong? You know, has somebody been hit by the aircraft as it took off?
We wondered whether somebody had committed suicide, had run towards the aircraft and thrown themselves into the engine, affected its performance, and that had brought it down. We really didn't know.
The runway investigation has stopped all flights in and out of Stansted Airport. The shutdown comes just days before Christmas.
The terminal was seething with people. The pressure on us was tremendous to get that runway open.
Korean airline representatives arrived at Stansted Airport this morning. They're here to talk to accident investigators, both to try to assess what's known about the crash as well as to answer questions.
And there are sure to be a lot of questions. The destruction of Flight 8509 is the 5th major accident for Korean Air in the past 2.5 years. If the AAIB can figure out what happened near Stansted, they may be able to break this deadly pattern.
Daylight and the remains of a 747 lying in a path of destruction on the edge of an English village.
It was a very confusing debris field. It takes a while for one to absorb the scene and to try and make sense of it all.
By daylight, they get their first good look at the point of impact. A massive crater surrounded on all sides by scattered debris.
In fact, what we were seeing on the runway was debris from the explosion, which had blown debris high into the air and had been carried downwind and just happened to deposit on the runway.
The far-flung wreckage also helped solve the mystery of what seemed to be a jawbone on the runway.
Closer examination the following morning revealed that it actually was a bit of twisted plastic.
Safety specialist Sid Hawkins now turns his attention to the shattered remnants of the plane's cargo.
If you can imagine 40, 50 tons of cargo, almost all of it packed in cardboard boxes, and the explosion being so severe that every piece has been destroyed, and it gives you an indication really of just how severe this explosion was.
He needs to know if any of it poses a risk to investigators.
We had a consignment of corrosive materials.
Hawkins learns that Flight 8509 also carried military detonating cord, 2 tons of whiskey, color printer cartridges, even an X-ray machine. But he soon establishes that none of it poses a serious threat.
We're able to determine that the dangerous goods from this aircraft had all been destroyed.
But there is one more significant risk Hawkins must assess, one that stems from the design of the plane itself.
We know that this aircraft carries depleted uranium in its tail section, both in the rudder and in the elevators.
The 747-200 series uses depleted uranium as ballast to improve stability in flight. But tests show that none of the radioactive material has escaped.
You feel then that it's safe enough for the guys to start work.
Meanwhile, investigators are still trying to learn if the aircraft broke up before crashing.
I did see a glow, which could have been the plane alight.
I noticed the engines were on fire before it hit.
I explained to the investigators that when I looked out the window, I saw the plane coming over, and then I saw flames coming out of an engine.
Dan's observation raises the possibility that the left side engines flamed out, causing the plane to roll to one side.
It's safe. But be careful down in through there.
To determine if the plane hit the ground intact, they carry out what they call the four corners search.
Have we got both wings? Have we got the tailplane? Have we got the fin and rudder? And the answer eventually was yes, we have, and we were satisfied that there had not been a structural failure of the aircraft in the air.
While locating the four corners, investigators also discover some very distinctive marks on the ground.
It was a long, slender gash, which was made by the wing, and then you could see where the nose had impacted further on. From the shape of the ground marks, you try and understand what attitude the aircraft was in when it hit the ground.
The ground scar gives investigators a revealing glimpse into the flight's final seconds.
The aircraft struck the ground at high speed, steep left bank, steep nose down, and it's an almighty amount of energy.
Of course, it could be that somehow or other the pilot's been misled by his instruments and has become what we call disorientated.
The team brings some of the aircraft's instruments back to the AAIB labs for examination.
We found a few pieces of the ADIs.
The ADI, or Attitude Director Indicator, is a flight instrument that displays the plane's bank and pitch.
when you're flying at night in cloud, there are no visual cues. So he has an artificial horizon or an attitude direction indicator in front of him.
Modern aircraft have 3 instruments, one in front of each pilot and a standby one in the center panel. So if one of them should fail, the pilots can compare their instruments with the standby instrument and see which 2 agree and which one disagrees.
We found only fragments, and we were able to forensically examine these.
They discover that the captain's artificial horizon seems to have malfunctioned. It was showing the plane flying level at the point of impact. That contradicts evidence found at the crash site. But without the plane's flight data recorder, investigators can't explain the discrepancy.
What we needed was that recorder to give us the confirmation of the exact flight path of the aircraft.
Pre-flight maintenance records would normally shed some light on the situation, but not in this case.
Technical log from this flight was not available to us. It had been destroyed in the impact, and unfortunately, a copy was not left at Stansted. It should have been.
For more information, investigators interview the crew that flew the plane to Stansted on the previous leg of the flight.
I need you to walk me through exactly what happened.
They told us that when they departed from Tashkent the day before, in good weather, in daylight conditions, they had to carry out a turn to the left. As the captain commenced the turn, his artificial horizon did not work in roll.
In the daylight, the pilot was able to get his bearings from the horizon outside.
In order to resolve this issue, the captain selected number 3 as his source, and his instrument worked perfectly. They continued the flight and landed uneventfully at Stansted.
After landing, the inbound crew left the terminal before the replacement crew arrived.
The normal practice is if a inbound crew were to meet the outbound crew, there would be a verbal handover, a debrief, if you like, of the state of the aircraft.
But that didn't happen. Instead, the only person that heard about the ADI problem is the Korean Air maintenance engineer.
Okay, I'll have a look.
Korean Airlines had dispatched an engineer to take charge of any work that needed to be done on it.
The Korean engineer didn't have the tools he needed for the job, so he enlisted some local help.
I need you to remove the captain's ADI.
The story of the repair only deepens the mystery. The inbound crew knew they had a faulty instrument and they had it fixed. And yet on takeoff, Captain Park's artificial horizon did not work according to the evidence found at the crash site. The Korean engineer is dead. The only person they can ask about the repair is the British mechanic who helped him.
The locally based engineer told us he removed the instrument from the panel, unplugged the wires at the back.
All right, that's our problem. Can you reset the pin?
And found what he believed to be a problem with the connector pins at the back of the instrument. He replaced the connector in the right way, put the instrument back into the instrument panel, and then carried out a test.
Looks good.
As far as the engineer was concerned, the problem was solved.
Had the maintenance actions actually fixed the defect?
They hope the answer will be found on the flight data recorder. It has finally been recovered at the crash site.
To find that in amongst all the wreckage at the bottom of a 30-foot crater took a considerable effort. It took 7 days to find it.
But when they download the data, something doesn't add up. The readout is showing that the plane's roll angle never exceeded 2 degrees.
Clearly it had gone in at a much steeper roll angle than that, like 90 degrees. So that set the alarm bells ringing. Why should that occur?
Why a Korean Air 747 crashed just moments after takeoff from London's Stansted Airport is a mystery investigators are only beginning to unravel. The flight data recorder from Korean Air 8509 reveals that the faulty ADI reported by the previous crew seems not to have been fixed after all. They need to understand how the fault in the plane's navigation system was for some reason misdiagnosed.
How exactly did your crew report this problem?
Upon landing, the inbound crew's flight engineer noted the problem with the ADI by entering a code in his technical log. He then mentioned it to the maintenance engineer.
Okay, I'll have a look.
The normal action is to take the code that's entered and then look in the corresponding fault isolation manual, which has the same corresponding numbers, and that would then tell him what the fault was and what he had to do about it to fix it.
But the Korean Air engineer didn't have a copy of the fault isolation manual. Without it, he couldn't correctly identify the proper repair. Instead, he tried to troubleshoot the problem as best he could.
All right, that's our problem.
This is when we go into the detailed evaluation of the aircraft manual, the component manuals, right down to the wiring manuals.
After an in-depth analysis of the plane's navigation system, they finally figure out what was wrong with the captain's artificial horizon. It was being fed corrupt information. The real problem lay deeper, with a device called an Inertial Navigation Unit, or INU. Units deep inside the airplane send pitch and roll data to the captain and first officer's ADIs. Investigators conclude that one of the INUs short-circuited.
It simply ended up in corrupting the roll information that was fed to both the flight data recorder and the captain's ADI.
All the maintenance work done on Flight 8509 was misdirected. What they had repaired was never the problem at all.
Really, they were barking up the wrong tree.
I need you to remove the captain's ADI.
If the fault isolation manual had been available, they might have deduced that the correct maintenance action was to replace the number 1 INU, not the captain's ADI.
The rectification action was completely ineffective. The aircraft took off with the same defect that it had arrived with.
An instrument failure is a rare occurrence. However, crews are trained to deal with it.
Checking each of the 3 ADIs should have allowed the captain to identify the problem. The recorded flight data shows that both the first officer's ADI and the backup instrument displayed the plane's correct bank angle. Only the captain's artificial horizon was wrong. How the crew dealt with that defect in the seconds after takeoff could be the key to understanding why the flight ended in disaster. Investigators finally have new insight into those crucial last moments.
Sir.
AAIB technicians have salvaged the recording from the badly damaged CVR.
대답해. 얼마나 연결될 것인지 그들이 묻고 있어. 네가 말하기 전에 그들이 무엇을 말하고 있었는지 확실해.
One of the most important things that was on that recorder was the sound of a warning horn going off in the cockpit as the aircraft departed from Stansted.
But even more significant than the sound of the alarm is what is not on the tape.
They seem to be ignoring the alarms completely.
There was no discussion about the fault with the artificial horizon.
The alarm is telling the pilots one of their ADIs is malfunctioning. They should check the third instrument to see which ADI is correct. But the pilots remain strangely silent.
The flight engineer saw the standby horizon, looked at the other instruments, and actually pointed out this problem to the captain.
Bank's not working.
But the captain did not respond to that, either in words or deeds.
Investigators are also troubled by the fact that the first officer, who had a working ADI, did nothing to save the plane.
Why didn't the first officer say anything? Here, he was in a situation where he was about to die. He knew that the instruments were at fault, the comparator buzzer was going off, and he said nothing.
Bank! Bank!
The co-pilot should have said to the captain, your ADI is not reading correctly.
He should have forcefully said to the captain, mine's correct, I have control, let me take control.
The correct response to that would have been, yes, you have control.
But the co-pilot said nothing.
The CVR also answers a lingering question concerning some of the eyewitness accounts of the crash.
The CVR gave no indication that there was a fire on board the aircraft. You would have heard of an engine fire bell, which is a very distinctive warning, and we didn't hear that.
The fact that some witnesses were wrong doesn't surprise Moss.
There's all sorts of things people can see in bad weather conditions at night. Reflections of the aircraft's lights or the navigation lights sometimes can mislead people into thinking there's a fire there.
Investigators now want to know more about the crew members who let a minor malfunction lead to a catastrophic crash.
We listened to the words on the tape, but of course they were in Korean. We had the translation in front of us, but it was very difficult to determine the tone of what was said and how it was said. And we had someone who spoke Korean listening to this conversation, telling us the social interaction between the two crew.
They can hear that prior to takeoff, the captain was becoming more and more agitated by the delays.
Korean Air 8509, please explain your delay.
Answer them. They're asking how long the delay will be. Make sure you understand what they're saying before you speak.
Stansted clearance, standing by for new flight plan for Milan.
The captain was very overbearing. He was very critical of the first officer.
And the first officer was quite subservient in this conversation. He did all the listening, the captain did all the talking.
So you'd say he's being condescending?
Miller can't help but wonder what would have happened if the captain had listened to the engineer's warning. He wants to know if there was enough time to save the plane. Using a flight simulator and data from the flight recorder, they recreate the entire flight. The simulation reveals that impact with the ground was not inevitable.
It was possible, just possible, to recover the aircraft about 500 feet above the ground, doing about 260 knots at 80 degrees a bank. If you knew what was happening, you could have just recovered the aircraft, just skimming the ground in doing so.
The results convince Miller and his team that they need to better understand how Korean Air trains its flight crews.
It was obvious from this accident that the crew interaction played a big part in this accident, so we needed to go to Korea to see how the crew were trained.
In Korea, Miller gets an opportunity to observe Korean Air flight training firsthand.
there was definitely a hierarchy between pilots. The captain was supposedly the older, the wiser, the more experienced, and the first officer was the younger, inexperienced apprentice. Crews were working in a very procedural way. There was not really much free thinking to deal with an unusual situation.
The crew dynamic observed in the Korean training session is strikingly similar to what was recorded in the cockpit of Flight 8509. Investigators dig into Captain Park's personal history.
A lot of the captains in Korean Air were people that had developed their skills in the military.
Captain Park had been a colonel, a pilot with a distinguished career flying small, lightweight fighter jets.
Korean culture at the time suggested that these pilots needed to hold a position that was commensurate with the rank that they had when they were in the military. So it would be a great loss of face for a colonel in the military to be given the job of a first officer. He would go into the company as a captain.
Park became a captain even though his experience was flying solo in fighter jets, not as part of a crew on large commercial jets. By piecing together the puzzle of miscommunications, unexpected glitches, and crew dynamics, investigators believe they finally understand why Korean Air 8509 hit the ground less than 60 seconds after lifting off from the runway.
This is inexcusable. If we hit one more delay.
Korean 8509, clear takeoff runway 23.
Clear for takeoff runway 23. Korean 8509. Clear for takeoff.
Finally.
A series of delays put Flight 8509 behind schedule, testing the patience of the captain. The first officer remained quiet, trying to avoid conflict with a senior colleague.
To operate any aircraft, you need the crew to be working as a team. You don't want an autocrat in one seat and somebody who's very subservient in the other.
V1, rotate. Positive rate confirmed.
Gear up.
Gear up.
You have to have the crew talking to each other, feeling free to comment and criticize if necessary what the other's doing.
The critical moment came as the captain turned his control column to the left. His artificial horizon didn't move.
And that would have been very confusing. He would have wondered why. And in fact, what he did was put more bank on and more bank and continued to increase the turn rate.
Bank! Bank!
The flight engineer knew that the aircraft was starting to bank at an extreme angle. But Captain Park ignored all warnings.
In fact, he had received a reprimand some months before because he had not correctly followed an instrument departure procedure. And we think that this was uppermost in his mind, that he had to follow the correct procedure to avoid getting another rap across the knuckles, I suppose.
To make matters worse, he had no visual reference and likely couldn't feel the drastic bank.
If the instrument is saying, no, you're straight and level, then that's what you believe, even though the aircraft is banked at quite a high angle.
Crews are trained to trust their instruments and not their senses. Captain Park trusted his ADI in spite of overwhelming evidence that it was wrong.
The first officer should have said to the captain, look at the warning buzzers going off. It's very difficult to understand his reactions or lack of reactions. But I think a lot of it is embedded within the culture I was at that time.
Fearing dishonor more than death itself, the first officer did not dare criticize his captain, or even attempt to correct his actions.
This crew were not operating as a crew, they were operating as one man with a couple of assistants.
The aircraft just continued to roll. 30 degrees, 40, 50, 60, 70, 80, 90 degrees of bank.
Investigators now suspect that the seeds of the deadly crash were sown hundreds of years before the 747 ever left the ground.
Sir.
For centuries, a rigid class structure based on social hierarchy defined Korean culture. Investigators have come to see how the Korean military, an honor-bound institution, has strongly influenced commercial aviation. It's now clear that strict adherence to cultural norms put the crew of Korean Air 8509 in danger from the moment they entered the cockpit.
It's very difficult to overcome entrenched cultural values.
The different stature of the two pilots was also reinforced by a disparity in military rank.
We believe that the cultural values within which these two people were raised was overwhelming in this instance.
The relationship between the two pilots was not that of equals. Just 2.5 years earlier, a Korean Air flight went down in the South Pacific, killing more than 200 people.
Korean Air had been going through quite a rough patch. One of their aircraft had been involved in an accident in Guam.
Poor crew communication and long-standing rules of hierarchy had also contributed to the crash in Guam.
Their reputation was not good. Then this accident had come along.
The US military stops using Korean Air to ferry its personnel in the Pacific region. The airline comes under strict scrutiny around the world. With the crash of Flight 8509, Korean Air's reputation is in ruins.
At a news conference, the Korean airline officials made the startling admission that military pilots, many of whom were recruited by the airline, sometimes take unnecessary risks.
Despite all the negative publicity for the struggling airline, investigators see a way to help Korean Air overcome its safety problems.
I think all accidents have a lesson or lessons to be learned that will improve aviation safety.
The AAIB recommends that all imported training materials be modified to better accommodate Korean culture. Korean Air's training programs are radically overhauled to improve pilot performance and foster a completely new culture within the cockpit.
After the accident in 1999, Korean Air, I believe, entered into a significant program to improve its safety record. That company have introduced a much more rigorous process, and they really have invested very, very heavily in the flight safety aspects that came out of this accident.
In this case, the issues of communication, the issues of how aircraft are maintained, and also the very important conclusions regarding cockpit resource management.
The statistics show that the safety record of Korean Air since these events around 1999 is such that it is now regarded as a very safe airline.
As a direct result of the crash of Flight 8509, Korean Air has been completely transformed. Since 1999, the airline has not had a single crash or fatality. It has become one of the most highly regarded airlines in the world.